In today's video, we are going to learn about logistic regression. Now, what exactly is this logistic regression? And how exactly is logistic regression different from linear regression? Now, let us learn about logistic regression. So, logistic regression is a classification algorithm that is used where the response variable is categorical in nature. You will be wondering, why am I saying logistic regression and it is written classification algorithm? Because logistic regression tries to find a linear relationship between the independent variable and the log odds ratio. In my future videos, I will be explaining the concept of log odds ratio in detail. So now, to understand, even though there is a regression attached to logistic regression, it is actually solving a classification problem. Hence, we are covering it under classification algorithm. And it is used when a response variable is categorical in nature, like whether a student has passed or failed in the examination, whether a person has diabetes or not, whether a person has corona or not. These are features and the dependent variable where the dependent variable is categorical in nature. The idea of logistic regression is to find a relationship between features and probability of a particular outcome. Over here, we are not predicting what outcome will come, but we are predicting the probability of occurrence of a particular outcome. Now, let us look at the different types of logistic regression. Now, there are three types of logistic regression. What is the first type? It is nothing but the binary logistic regression. What exactly is this binary logistic regression? It is a scenario wherein the target variable has only two possible outcomes, 0 and 1. For example, whether a student has passed an examination or not. So you have two possible outcomes, pass and fail, whether a person has diabetes or not. You have two outcomes, having diabetes or not having diabetes, and so on and so forth. The next type is the multinomial logistic regression. Over here, the target variable can have three or more possible values without any order. So for example, the type of mushrooms, the type of wine, the type of cuisines, these are all multinomial. You have more than three outcomes. The best part about multinomial logistic regression is that there is no order to these different types. It's not like after one, the other comes and so on and so forth. Over here, the order is not important at all. The final one is ordinal logistic regression. By the term ordinal, it is clear that there is going to be some order over here. So, in this, the target variable can have three or more values with ordering. Now, when we study any model, we have to study the assumptions. Without the assumptions, the model cannot stand on its own. So, like linear regression, even logistic regression has a set of assumptions. Now, let us look at those assumptions. So, the first assumption states that by default, logistic regression assumes that the outcome variable is binary. So, we have outcomes like pass and fail, having corona or not, having diabetes or not, only two outcomes. The second assumption states that the relationship between the logit, also known as log odds of outcome, and each continuous independent variable is linear. This is the reason why logistic regression is called as logistic regression and not called as logistic classification, because over here we are trying to build a linear relationship between the continuous independent variable and the logit. Now let us look at the third assumption. No highly influential data point. So an outlier is like an exception value. It is totally different from all the data points. Now, if such outliers exist, our logistic regression will not give us appropriate results. Absence of multicollinearity. Multicollinearity means you have different independent variables which are correlated with each other. If we want to build a logistic regression, we have to ensure that the independent variables are not correlated with each other. Now, the fifth assumption states that the observations must be independent of each other. So, the observations should not be dependent on the previous observation. And finally, there should be an adequate amount of observations for each independent variable in the data set in order to avoid overfitting model. Now, we always are looking for bigger data sets because if we have bigger data sets, we will be able to avoid the overfitting problem. Now, these were the assumption of logistic regression. Like any model, logistic regression has certain pros and it has certain cons. Now, let us look at the pros and cons of logistic regression. Now, let us look at the advantages and disadvantages of logistic regression. Logistic regression is very easy to understand. It is very easy to implement. You do not need much time in training. It requires less training. It performs well for simple data set as well as when the data is linearly separable. Here lies a problem with logistic regression. It tries to establish a linear relationship between the independent variable and the logic. But in real world scenario, you will seldom have data sets which will be linearly separable. It doesn't make any assumptions about the distribution of classes in feature space. A logistic regression model is less likely to be overfitted, but it can overfit in high dimensional data. To avoid the overfitting scenario, one may consider regularization. In high dimension, there is a high chance that it will overfit. And in such a scenario, we are going to apply the regularization technique. As I had said earlier, logistic regression is easier to implement, interpret, and very efficient to train. Now, let us look at the cons of logistic regression. Sometimes a lot of feature engineering is required. A lot of transformation of variables are required before applying logistic regression. If the independent features are correlated with each other, it may affect the performance of the classifier. That is, if there is multicollinearity, our results will not be appropriate. It, it's quite sensitive to noise and overfitting. So basically, when your model is overfitting, what exactly happens is your model is trained on noise. It is not trained on the actual points, and as a result, you have overfitting. Overfitting leads to not able to generalize the results for future. Hence, we have to avoid overfitting. Logistic regression should not be used if the number of observation is lesser than the number of features. Otherwise, it may lead to overfitting. So the number of observations has to be greater than the number of features. Otherwise, there will be a problem of overfitting. In linear regression, there is a linear relationship between dependent and independent variable, but in logistic regression, independent variables are linearly related to the log odds. So, these were the advantages and disadvantages of logistic regression. I hope the idea of logistic regression, the different types of logistic regression, the assumptions behind logistic regression, the pros and cons of logistic regression is clear for one and all. Thank you.